Okay, we're looking at a B&K Precision 4.5 digit true RMS multimeter. It's an LCD type, and right now I've got it connected up to a Fluke 343A DC voltage calibrator, and we're going to run this thing through some DC voltage tests to see how it performs. We are on the lowest of the settings right now, so we are reading 200 millivolts maximum with 2-digit decibel place, so we'll be able to get to the tens of microvolts. See how that does. Let's go ahead and bring this thing online. Okay. Everything is there. Alright, so to begin with, we're going to start out with 1 or 2 microvolt, excuse me, this would be about 10 or 20 microvolts. Looks like 10. So we got a reading of 1. And we're going to go ahead and bring it up. Let's see if it's a tenth of a microvolt, then we should be able to bring it up a step at a time here by doing that. There we go. So there is, I've got 1 microvolt going on, and we got a reading of 2. 2 microvolts, we get 3, 4, 5, 6, 7. So we may be a microvolt off, but we're getting the resolution that we need to see the difference in the readings. Oops, I hit the wrong button. Excuse me. Let's go to 8, 9. Okay. Now let's go ahead and take the hundreds of a microvolt. We'll go up a step at a time here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, now let's go to the millivolt. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, we resolved to the millivolt, so let's go tens of millivolts. 10, 20, 30, 40, 50, 60. I'm going to go ahead and back the 9s off again. It's obvious that we picked up another millivolt. That's a product of the calibrator as you get higher in the numbers. Alright. There's 60, there's 70, 80, 90, and then let's go to the 100th position. There we go. So there's 190. And we could get up to 199, 99. Then you'll trip over into 200. So let's go ahead and raise her up another scale. Alright. And go up 2. This would be 200 millivolts, 300, 400, 500, 600, 700, 800, 900. Okay, and then let's go ahead and go to 1.9 volts. We're on the 2-volt scale, so let's go ahead and take her up another step in the scale. And let's go ahead and go 2, 3, 4, 5, 6, 7, 8, 9, and here would be 10. Alright. Now in order for me to go higher, I have to take all these back down again, and we'll raise the fluke up to its next range. So let's go ahead and do that. Stand by. Those are zeroed. We go up to the 100-volt position. We can go back online, and we want to read, let's read 10 volts. 10. Here's 20. That's overscale. Take it up to 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 will take it over range, so we're going to take her up again. Okay, and we'll go 20, 30, 40, 50, 60, 70, 80, 90. Okay, and then let's go ahead and take the fluke up another range. Alright, now we will go 100. It's 100 volts. And we are on the 200 volt range, so let's go ahead and take her up to 190. Right, there's 190. Alright, let's take the meter up to the 1000 volt range. We are reading 100 right now. There's 200, 300, 400, 500, 600, 700, 800, 900, and here's 1000. Alright. So we went from we went from 10 microvolts up to 1000 volts. And right now the worst error we read is 0.7 over 1000. Very small error number. And you can be pretty sure that the error is coming from the calibrator, because the calibrator is adding up all these voltages, so every time I step this thing up to a next level, a next decade, I'm introducing the chance of bringing in something that's a fraction of that value. The big thing was that we saw the resolution in the lower ranges, so you were able to discern the difference between 10 and 20 microvolts. So that worked very well. Okay, I'm going to take the voltage off of here. And we're going to go and read resistance. So let's go ahead and I have a switch box here that contains a number of precision resistors. Alright, this happens to be a 100 ohm 1%er, so we will go to the lowest range for ohms. So we'll put ohms on here. And it's a 200 ohm range. We are reading a 100 ohm 1% resistor and we're getting 100.06. At 1% we could get 101, so or we could get 99 for that matter. So we're right on. Let's take a look at the 500. We have to go up to the next range. This is a 2000 ohm range. And we are getting something between 500 and 500.1. And this is a 500 ohm 0.01% resistor, so believe we could be off by 0.05, which would be about right. So when we're flashing that last digit, it's rounding up whatever that value is. Let us go to 1.899 thousand at 0.1%, and we are getting 1.8992. So 1899.2 ohms. We're 0.2 ohms over the 1899 using 0.1%. So I have a calculator nearby. Let me quickly figure this out. 0.2 divided by 1899. That's a 0.06% error. So certainly smaller than 0.1. Let's go to 10K. We have to go up another range. And we are reading 10.006 and falling. 5 now. Certainly that's within spec. That's a 0.1%er. Alright, let's go to the next range. We're on 200,000 ohm range. Reading a 33.2 ohm resistor, 33.2 thousand ohm at 0.01%. So we're right on. Exactly what we wanted. 100,000 ohm at 0.1%. And we are getting 100. 0.09 to 0.1, so we're on the high end of the tolerance, but we're within tolerance. 196,000 ohms at 0.1%. That also is within tolerance. Next range, 475. 475,000 ohms, 0.1%. If we read under 475.475, we can't read 475. The best we could read would be 0.5 rounded up. 0.475 rounded is 0.5. So we are right at the high tolerance side of that limit, but we're there. 1.5 megohm at 1%. We have 1.5. 0.6, certainly that's within spec. 4.7 megohms, we have to go to the next range. We have a 20 million ohm range. 4.7. 4.747 would be intolerance. We got 4.72, we're good. And finally, we got a 10 megohm resistor at 1%. and we are getting 10.0. We'll call it 10.08. We are under the 1%, so we're good there too. So we just went through the entire resistance scale, and we've matched the values that we have on hand. So there's our DC is right on the money, and our resistance is right on the money. We're reading very well here. Along with being able to read resistance, voltage, and amperage, this is also a continuity tester with an audible continuity alarm. You can listen to it here. And that can be turned off or on. And you also see that we have a resistance measurement here that's showing 0, or we go open. Put it back on. So that's working. Okay, we're feeding an AC signal in from this Ray-Cal-Dana signal generator, which can produce up to nearly 20 volts. So, and it's variable AC frequency. And right now we're on the 200 millivolt scale, and I'm comparing the bk true RMS multimeter to a Keithley 177 microvolt DMM. It is not a true RMS type. But right now we are seeing that both of them are in agreement almost perfectly at 119 millivolts. And I can adjust that. 184.4.5, 184.40 on the bk2833, 184.5. So there's about a tenth of a millivolt difference between the two right now, with the Keithley reading a little bit higher, which obviously we can get up close to the 200 millivolt. Oops, we went over. All right. About a tenth of a millivolt different at 182. I do not have an AC voltage standard. I do have a DC voltage standard, so we were able to do a wonderful job at checking the calibration against the standard. I have precision resistors, so that was easy to check. We were able to test the resistance readings. Not so easy with the AC without a standard, so I'm comparing it to a meter that is similar, and we're getting close, very close readings. But let's keep going. We'll try a 2 volt range, and raise ourselves up here. Let's get ourselves over a volt. I'll change my output range here in a moment. But right now we are at 0.8967 on the Keithley, 0.8954 on the RMS B&K. Actually, both of them came down just a little bit. Alright, I'm going to go ahead and change range. Alright, we are getting so let's let it stabilize a moment. 1.7896 on the Keithley, 1.767 4.7 on the B&K. So we are about maybe 3 millivolts different. 3 millivolts out of 1.78 roughly. Okay, let's go ahead and raise her up again. We'll have to change our range. We're on the 20 volt range on both. And 4.7 volts on the B&K, 4.712 on the Keithley. Keithley has a tendency to read the peak. The RMS is going to be probably a little lower. But can I say that it's dead accurate? I could not. I don't have a standard. Alright, let's take her up far as she'll go here. Alright, here we're getting 10.994 volts on the Keithley and 10.994 volts on the B&K. This is at 60 hertz. Let's change our value. Alright. And we get 8.768 and 8.765, and dropping a millivolt in each case on both meters, flashing up and down 1 millivolt. So we are no more than I'd say 3 millivolts apart right now. Let's go ahead and drop her down again. .254 on the Keithley, 5.244 on the B&K. So we are now about 10 millivolts apart at this lower setting. Let's go ahead and reduce our range. Alright, I have, this is on the 2 volt range. I'm reading 1.1035 on the Keithley, 1.1021 on the B&K. So we are about a millivolt apart. So we're getting good readings. I think it's a very good meter. That's my belief. Certainly good in the DC mode, excellent in the resistance mode, and I think we're getting very good readings here in the AC as well. Continuity checker is great. It's good looking. It's working great. It's a winner. Alright, my Keithley says that I'm getting 200.7 ohms from this resistor. And I am now going to switch to reading voltage across it, and I'm going to connect up an amperage through it. Okay, and like right now we are reading 0.36 milliamps. We're getting voltage across the resistor of 0.0755. So 0.0755 divided by 200.7, and I should be reading 0.037. According to the calculation, I'm getting 0.036. So that's remarkably close. So let's go ahead and kick ourselves up current-wise. All right, we kicked it up. I've got 3.355 volts divided by 200.7, so that would be 16.7. I've got 16.6 roughly. 16.55, 16.6. So it is reading that fairly well. Let's go ahead and kick her up a little more. Alright. I'm getting 9.8 volts. And I should be reading 0.0488. According to this, I'm reading I'm getting 48.35. 48.4 instead of 48.8 milliamps. So we got 48 milliamps anyway. That's perfect. Let us go ahead and we will reduce the amperage and change scales. Let's go to the 20 milliamp scale and I'm getting 3.7 volts divided by 200.7 would be 0.0184, so 18.4, and by golly I'm getting 18.4, so that's right on. Let's reduce our range to the low end. I'm getting 0.744 volts. And that would mean that I should be getting 3.7 milliamps, and I'm getting 3.7 milliamps, so perfect. And if we reduce our scale again, and reduce our voltage. Let's go ahead and give ourselves, we are now on the 2 milliamp scale. Alright, I'm going to stop right there. And I'm getting 0.3015. And it's telling me I should have 1.5 milliamps, and I am getting 1.5 milliamps. So, beautiful. So our ammeter is working. And it seems to be calibrated. It seems to be working fine. As I am reading my voltage across this resistor that I measured the resistance of. So there you go. Thank you.